Now I want to talk a little bit about multiplication. This may sound as something very basic that we all know, but I think in school we see multiplication in maybe in a more theoretical way, or we do a lot of exercises, but we normally cannot see, like we can see here in processing, the effects of our numbers, how we can change colors, sizes, and positions. So I'm gonna start talking about the multiplication and the number 1. So I have here a very simple program that is just setting the size and colors, but we're not gonna use any of that for now. I'm just gonna print some examples. So to multiply, we've mentioned before, we use this sign here, the asterisk. What happens when you multiply any number by 1? You can see the result here. You always get exactly the same number. If I multiply 150 by 1, then I get 150. If I multiply 153 by 1, then I get 153. So the number 1 is a special number. What happens when I multiply by a number that is larger than 1? For example, 2. You can see that the number I get is larger than the original. The original number is 153, and now I'm getting 306. If I multiply by 2, it's double that number. If I multiply by 3, then it's even a larger number. What happens when I multiply by a number larger than 1, but not so large, like 1.1? Then you can see it's increasing less. I'm going up from 153 to 168. If I would go to 1,03, then the increase is not very large. I go just from 153 to 157. So we know that if this number gets smaller and smaller, closer to 1, then the number will change not very much. Now I'm just going from 153 to 154. Now this is interesting. What happens when I go down a little bit? Now it's a number smaller than 1. We know that number equal to 1, then we get the same result. If it's smaller than 1, now we're getting smaller numbers. You can see when I multiply by 0.9, I go down from 153 to 137. If I multiply by 0.1, then I get only 15.3. This is the same like dividing by 10. Multiply by 0.01 would be the same like dividing by 100. So now this is 1%. I get 1% of this number. I'd convert 153 into 1,53. So I want you to remember that there's this number 1. If you multiply any number by 1, you get the same result. If it's a little bit higher, then you get higher numbers. If it's a bit below 1, then you get smaller numbers. We can see this now in practice. Let's make some graphics so you can see how this is working. I'm gonna draw an ellipse on the middle of the screen. Remember now our axes are in the middle of the screen, so if I draw an ellipse at 0, 0, it's right on the middle. And I'm gonna use here the width and the height of the screen, so it's gonna cover the whole screen. What happens if I multiply now these numbers by something below 1, like 0.9? So you can see the circle gets smaller. If I multiply by 0.1, then this circle is only 10% of the width and 10% of the height. It's like 1/10. And the smaller the number, then the smaller the circle I get. Now it's just like a tiny dot. If I would multiply by a number greater than 1, like 1.2, then you see it's growing. It's almost covering the whole screen now. So I think you get the idea. Let's see how we can use this to animate objects at different speeds. To animate, I'm gonna have to create here a setup function, and all these lines are gonna be inside the setup function. And now I'm gonna draw something that's moving. So I'm gonna use a variable to keep track of the horizontal position. I'm gonna start at 0. And I will draw 3 ellipses with different colors. I will use a red color. Then I will use a green color. And finally I will use a blue color. And I'm gonna draw 3 ellipses. And this will be at 0, no, not 0, wherever my variable is saying, so x. And yes, 0 then vertically. And it's gonna be a small circle, just like 10 and 10. My second ellipse is gonna be also the same horizontal position, but I'm gonna draw it a little bit lower, like at 40 pixels down. And the same size like the previous circle. Finally, the next ellipse is gonna be in the same horizontal position and even lower. I don't want to keep them exactly in the same vertical position because otherwise I will not see them. One will be on top of each other. Here's again a semicolon. So now I should have these 3. Okay, now what happened? Things moved up here. You can barely see them because the translate is reset. You have to put the translate always inside the draw function. So now they should be aligned here. Now I'm gonna make them move. I'm not changing the x yet, so I'm gonna say x equals x plus 1. So now all the circles are moving to the right. To avoid having this trail, I'm gonna move the background also here inside the draw function, so the screen is cleared on each frame. Now I should see these 3 circles moving at the same speed. Now comes the interesting part, what I do with multiplication. What if I multiply the x position by some number smaller than 1, for example half, 0.5. And the third circle also, I will multiply this number by 0.25. So now you can see that they are not going to be exactly on the same horizontal position. What's happening now? So you can see now the first circle is moving faster. This one is moving at half of the speed. I'm multiplying by 0.5. And the blue ball down there is moving at 1/4 of the first circle. You can make the speed difference smaller. If I multiply here by 0.9 and then 0.8, then still the first circle would be the fastest, and the second would be a bit slower, and the third even a little bit slower, but you can hardly see, it's not a big difference. Now what happens if I multiply the second one by 2, and this I will multiply by 0.5. So now the second circle is twice as fast as the first circle. And the third circle is going half of the speed of the first circle. As a final example for today's episode, I'm gonna modify the program we created the other day, where we had these 5 rectangles spinning, so they will spin at different speeds. So you can see at the top here we have this R we are using as rotation. All of our rectangles are rotating at the same speed. We want to change this. So we could add here a 4th parameter that will be our rotation. So currently this would be R for all of our circles. That's how we have it now. All are gonna rotate this amount, R. I have to add a 4th parameter here. So I will call it rot, like rotation. And here, instead of rotating R, I will rotate rot. This here is the variable my function receives. So when I call this function, draw rotating rectangle, I'm sending 4 parameters. The x value, the y value, the size of my rectangle, and how much I should rotate this rectangle. If I now run this program, nothing's gonna change. because I have the same rotation for all of them. But now I can easily change here, multiply by a coefficient. I multiply by different values, like times 1.2 and times 2.3. I'm typing just 3 random values. So now each of those rectangles are gonna rotate at different speeds. You can see this here is the slowest and the center one is the fastest. So you can see now, remember that when we multiply by 1, we get the same value. When we multiply by a number below 1, then we get a smaller number. So we are having here less rotation for these two rectangles. And in these cases, we are multiplying by a number larger than 1. So we're getting a faster rotation.